Hey guys, I'm Yoogi and I'll be explaining the problems A to E in the Codeforces Round 923. So first for question A, this is the question. We have a horizontal strip of n cells and each cell is white or black. So we have to choose a continuous segment of cells, that is a subarray of that strip, and paint everything in that white. So all the black cells would become white and all the white ones would of course remain white. So we need to find the minimum length of such a segment that we can choose. So as a test case, I'm going to be taking this one, which I've already written here. So we'll have white, black, black, white, black, white. So the idea behind this problem is quite simple. We basically we need to make all the black white, right? So we take the first occurrence of a black segment and the last a black cell and the last occurrence of a black cell, and everything from here to here we have to paint white. So, and since we're taking only one segment, we'll have to take this entire segment. So to get the answer, we just find the first occurrence of a black, the last occurrence of a black, and find the distance between that. And if there are no blacks, then it will just be 0. So that is what I have done here in this code. So FB is the first occurrence of a black cell, LB is the last occurrence of a black cell. Initially I set them to -1 just to indicate that no black cell has been found, and I iterate through the n characters of the strip, and if I input the character, and if I come across a black character and the first black has not been found, that is, it's still -1, I set that to be the first, and I just keep updating the last black character every time I encounter a new one, so that in the end, after going through everything, LB will contain the last encountered black character. So once I do that, FB will have the first encountered black character, LB will be the last encountered black character, and given the endpoints of a segment, the distance between them is just LB minus FB plus 1, which is basically, for example, here the indexes are 0, 1, 2, 3, 4 and 5. So LB in this case would be 1 and RB would be 4, and the length we need is 1, 2, 3, 4, the length of the segment. So that's basically 4 minus 1 plus 1, and so the answer is just LB minus RB plus 4. This is accepted. Okay, now for problem B. This is the question. We have a string of length n consisting of only the lowercase Latin letters A to Z, and we are given its trace. So the trace is basically an array of n integers where n is the length of the string, such that A of I is the number of indices j smaller than I, such that Si equals Sj. So basically, in the string abracadabra, let's take this A, which is the 6th character. So the 6th character of the 6th element of the trace will be the number of occurrences of this A before in the indexes 1 to 5 or 0 to 4. So that is 2. So the 6th will be 1, 2, 3, 4, 5, 6, which is 2. So here this is how we construct a trace from the string, but we have the trace and we have to get the string, any string s from which it could have been obtained. So yeah, let's look at this example. We'll use the same thing and try to construct a string from this. So the approach to this problem is basically just a greedy approach, a brute force approach. I'm going to go through every index of this and put in the first character that works. So for example, here the character at the 4th place should have occurred exactly once before in this array, and it could have occurred anywhere in the 1st, 2nd or 3rd positions. So it doesn't really matter which. I'm just going to assume it would have occurred in the 1st position. So let's go over it once. I will put let's take a series of letters A, B, C, D, E, F, G. So 0. So I'll just put A here because nothing has ever occurred before, and I'm going to keep a count. I have put A once before. Then for the next one, this also 0, so it shouldn't have occurred before. With the first character that hasn't occurred before is a B, so I'm going to put a B there, and I'm going to keep a count. B has occurred once, and then again a 0, so it has to be a character which has not occurred before. So I'm going to put in a C and keep the count. C has occurred once. Now we have a 1, so the whatever character is here should have occurred once before in this array. So I'm going to look at all the characters from A to Z and find the first character that has occurred exactly once before. That character happens to be A. I go from A to Z, right? So I see that A has occurred once before. So I just put A here and increase this by 2. Increase this by 1, sorry. Make it 2. So then I see another 0. So this 0, again, this should be a character which has never occurred before, and in this case it will be A has occurred, B has occurred, C has occurred, D has not occurred. So I'll add a D here and increase the count of D to 1. Now I see a 2. So whatever character is here must have occurred 2 times before, and the first such character is an A. So I'll put an A here. And then again a 0. E has never occurred before, so E. And since A has occurred here, I should have updated this to 3, which I didn't. I will do now. Right. Now the character here must have occurred 3 times before. The first is an A, so this is updated to 4, and I put an A here. Now the character here must have occurred exactly once before, and the first such character is a B, because A has occurred 4 times. So I put a B here and make this 2, and then this should also be a 1, so it should have occurred once before. So I put a C here and make this 2, and this is a 4, so this whatever character is here must have occurred 4 times before. I can see that it has to be an A, so I put an A here, and that is an example of a string. So depending on the series of alphabets you take, you'll get a different value. So for abracadabra, you take, instead of A, B, C, D, E as the order you search to the alphabets, it will be something else. So this is what I have done in my solution. So I input the trace as A, and I keep a map that maps a character to an integer, basically the number of times that character has occurred till now. And this is just a series of alphabets I chose, which is like easiest to type on the keyboard. So then for every character in the answer, I basically go through every alphabet in this order, see if the number of times that alphabet has occurred before is equal to the value of the trace at that index, and if it is so, that is the character that I will add. And once I add that character, I will increase the frequency of that character by 1. And then once I have filled in that space, I don't have to look through any more characters, so I just break out of that and move on to the next I. And in the end, I just display the answer. So this works. Okay, so we'll now look at problem C. We have 2 arrays, one A with n integers and one B with m integers, and we are given an even number k. So we'll have to choose exactly k by 2 elements from A and exactly k by 2 elements from B, in such a way that when combining these total k elements, we'll get all the integers from 1 to k. So let's look at this example. We have A to be this array and B to be this, and k is 6. So here we can take the numbers 2, 3 and 6 from A and the numbers 1, 4 and 5 from B, so that when combining we get all integers from 1 to 6. But in this case we cannot do any such thing. So our job is to just find out whether we can or we cannot, print a yes or a no. So yeah, these are the two test cases I've taken, the same as what we just saw. So in the first test case, see, the elements have to, all the integers from 1 to k have to come from either a or b. So those integers can be present in a or b or in both or in neither. So I'm just gonna find out for every integer from 1 to 6 whether it's present in only a or only b, or in both a and b, or in neither a and b. So that's what I've done here. I've written up the table for all integers from 1 to 6 whether it's present in a and b, and after counting I get that there are 2 integers that are present only in a, 2 present only in b, and 2 present in both a and b. Now all the integers that are present in a we have to take from a, because we can't get them from b. It has to come from a. So these 2 integers have to be taken from a. Similarly, these 2 integers have to be taken from b. So we already have 2 integers from a and 2 integers from b, and we need to take 1 more from a and 1 more from b. So the integers that are present in both a and b, they can be taken from either a or b, right? So here there are 2 such integers, one of which we will take from a and one of which we will take from b, because we need exactly 3 from a and exactly 3 from b. So in what case will this not be possible? That is, in what case will we not be able to split this both value such that we get exactly k by 2 k by 2? Well, if there are more than k by 2 elements which are only in a, or more than k by 2 integers which are only in b, then it won't be possible, right? So that's what happens here. There are 4 integers which are present only in a, and 1 integer which is present only in b, and 1 integer which is present in both a and b. So these 4 integers we will have to take from a, and but we can take only at most 3. So this is, in this case we won't be able to find such a choice of k by 2 integers in a. So that's the logic. That's the logic for this question, which is what I have done here. So I just get the arrays a and b, and I create a 2D vector where basically for every integer from 1 to k, the present of I of 0 will be whether it's present in a or not, present of I of 1 will be whether it's present in b or not, and I go through every element in a and update it, I go through every element in b and update it, and I count number of a only, b only, both, and number of elements are in neither. If neither is greater than 0, then obviously it's not possible. If a only is greater than k by 2, it's not possible. If b only is greater than k by 2, if it's not possible. And if none of these are there, then it's possible. So that's the solution. Okay, so now we look at problem D. Right, the question is pretty simple. We have an array of n integers and we have some queries. So given a query which is represented by L and R, we have to find 2 indices I and j such that I and j are both between L and R, and the ith element and the jth element of the array are unequal, right? So if there doesn't exist such an I or j, we output just -1 and -1. So I've drawn up an example here. Let's take this array, and right. So now let's say that all the elements from L to R are equal. In that case, we can't find 2 distinct elements, and therefore such a pair won't exist. But if there are at least 2 distinct elements in the range L to R, then we know for sure that such a pair, at least one pair exists. And we can also say that there exists a pair such that one of the either I or j is R itself, because whatever R is, if there are at least 2 distinct elements in the segment L to R, then there must be at least one other element that is not equal to R, right? So we can find at least one pair which has R in it. So to simplify the solution for all queries, we are going to include R as one of our endpoints of either I or j. So right, now how will we go about that? What we can do is, for every element in this array, we can find the closest element to it before it that is not equal to it. So for this 20, that would be this. For this 20, that will be this 30. For this 20 also, it will be this 30. For this, it will be this 20. Here it will be this 20. And for this 20, it will be this 10. Let me just index this. Now, so what is the best way we can find this thing? We can see that if we have like a string of consecutive equal numbers, like for example this 20 and this 20, it is index 1 and index 2, both will have the same previous unequal index, right? So both of these will have 0 as their as the closest element that is not equal to it. And if we have two consecutive elements that are unequal, then for the latter element it will just be the index of the previous element. So for example 20 and 10, that is index 2 and 3, they are unequal. So for index 3 it will just be index 2. The closest to it that is not equal will just be index 2. And since it's two consecutive things, again it'll be the same thing as the one previous, so it'll just be index 2 again. And these two are not equal, so this will have an index of, so the value for this will be this index 4. So, and for the first one there is nothing before it, so we can't find any such thing, so it'll just be a -1 here. Right. Now we can get this array in O of n time by doing something like, we just go through every index, check if it is equal to the previous value. If it is equal, we just copy that value into it. So for example 20 is equal to 20, so we just copy the 0 here. 10 is equal to 10, so we just copy this 2 here. And if it is not equal, we take the index of the previous element. So this is 20 is not equal to 10, so we bring this 2 out here. 10 is not equal to 20, so we bring this 4 here. 30 not equal to 20, so we bring this 0 here. So once we find this array, given any query, let's look at two queries. Let's look at L equals 1, R equals 2, and L equals 1, R equals 4. So for the first query, we have L equals 1 and R equals 2. So then we are taking R to be part of our set, right? Our answer, right? So we take R, which is 2, and the closest element to it that is not equal to R, which is index 0. But index 0 is not in this range. So the closest element to this, which is not equal to it, is not in this range, which means in this range there doesn't exist another element which is not equal to R, right? So there doesn't exist a pair in the range 1 to 2. So this will just be outputting -1, -1. But let's take L is 1 and R is 4. Then we get a including R, we get a corresponding value of 2. And this 2 is in the range 1 to 4, which is basically this index. So there exists a pair 2, I equals 2 and j equals 4, such that a of I is not equal to a of j. So here we'll just print R, the value of R, which is 4, and the value of the this 2, that is the corresponding value in this new array we construct. So this will be the answer for this. So that's it. This can be applied to any array, and here is the code for it. The new array I'm constructing, I've named it as previous difference prev diff here, and so I input array A, and the previous difference for 0 I just set it to be -1. So for all elements from 1 to n -1, that is, if it is equal to the one just before, that is if a of I is equal to a of I -1, I set the previous difference of I to be previous difference of I -1. which is what we do here and here. And if it is not equal, I just do previous difference of I is I minus 1, which is what we do here, bringing the 2 down, 0 down, 4 down. And then once that is there, I just process all the queries, get LR, and the minus and the adding 1 is just to adjust for 1 indexing and 0 indexing. And that's the answer, which gets accepted. That's it for problem D. Right, so now we look at problem E. We're given two integers n and k, where k is even. And we have to construct a k-level permutation of length n. So a permutation is basically an array of length n consisting the n distinct integers from 1 to n in any order. No number can repeat, and no number which is not from 1 to n can occur. So 2, 3, 1, 5, 4 is a permutation, but 1, 2, 2 is not because 2 repeats. 0, 1, 2 is not because 0 is there and 3 is not there. And so a k-level permutation is when we take all the sums of continuous segments of length k. That is, if k is 3, then the continuous segments will be 2, 3, 1, 3, 1, 5, 1, 5, 4. Then if we take the sums, then the sums should differ by no more than 1. So formally we can say, let's assume Si is basically the sum of the first k elements from starting from index I. Then the maximum value of S minus the minimum value of S should be at most 1. And we have to find any k-level permutation of length n. So that's the question. Let's get on the solution. So I've just drawn an arbitrary long thing. N can be anything, with elements a0, a1, a2 all the way up till a2k plus 1 here. So now let's take the first k elements, right? So let's say the sum is S0, and the sum of the first k plus 1 elements, the first k elements, the second set of k elements, that is starting from a1, is S1. Then S1 minus S, we can say, since this is a permutation, AK cannot be equal to A0, right? And everything else is common. Therefore, we can say for sure that S1 is not equal to S0. Now, without loss of generality, we can assume that S1 is S0 plus 1. It can't be plus 2 because the difference must be at most 1. It can be either minus 1 or plus 1, but we're just going to assume S1 is S0, S0 plus 1. Then we can see that AK, if S1 equals S0 plus 1, then AK equals A0 plus 1, right? Then if S1 equals S0 plus 1, let's take S2, which is this range, right? S1 is this range. Right, now let's take S2, which is the one from A2 to AK plus 2. Sorry, this is S1. A2 to AK plus 1. So now S2 cannot be equal to S1 because A1 cannot be equal to AK plus 1, and S2 can either be S1 plus 1 or S1 minus 1. But if S2 equals S1 plus 1, then S2 minus S0 equals 2, which is not possible, which disobeys the conditions. Therefore, S2 must be S1 minus 1. So AK plus 1 equals A1 minus 1. This logic can be extended throughout. So what we'll get is S0 plus 1 is S1, minus 1 is S2, plus is S3, and so on until whatever s. So it'll keep alternating, right? So ak must be 1 plus a naught, ak plus 1 must be a1 minus 1, ak plus 2 must be a2 plus 1, because again it keeps alternating, ak plus 3 must be a3 minus 1, and so on. So let's take this now. Okay, the other thing is s0, from s0 to s1 we increase, from s2 to s3 we increase. So what we can see is from an even s to an odd s we increase, right? And since ak is even, from sk to sk plus 1 also we will increase. So ak to whatever's before a2k, that will be sk, right? So from sk to sk plus 1 is also an increase, which means a 2k plus 1 must, no, yeah, I mean a2k must be 1 plus ak, because sk to sk plus 1 is an increase. So from this what we can get is, we can write down a sequence s0, sk, s2k, and so on, which is increasing by 1 each time. And then similarly we can take, and then right, if we look at s1 to s2, that's a decrease, and since ak to sk plus 1 is also a decrease, then sk plus 1 to, I mean increase, sk plus 1 to sk plus 2 must be a decrease. So s1 to s2 is a decrease, sk plus 1 to sk plus 2 is a decrease. We get a similar thing, but instead of increasing we are decreasing here. So from that we'll get the series s1, sk plus 1, so on, decreases by 1. And then again, using the same logic, we'll be able to say s2, sk plus 2, s2k plus 2 increases by 1, s3, sk plus 3, s2k plus 3 decreases by 1 every time, and so on. That's, you get it. So that will provide us for a way to construct our permutation. So what we do is, we start with the position 0. Okay, let's take an example, 13 4. Yeah, n is 13 and k is 4, right? So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So we know that s1, this is s0, s4 will be 1, 2, 3, 4, and then there will be s8 and s12 and so on, right? So that increases by 1. So let's just take s0 to be 1, then s4 will, mean a0 to be 1, then a4 will be 1 plus 1, which is 2, and a8 will be 2 plus 1, which is 3, then a12 will be 3 plus 1, which is 4. Now I'm saying a1 is also increasing because we can see that a1 is basically very similar to s1, right? Since the difference between sk and s0 is the difference between ak and a0. So that's why I can say that since s0, sk, s2k increases by 1, a0, ak, a2k also increases by 1. So that's why we get 1, 2, 3, 4. Then we also have s1, sk1, sk plus 1, s2k plus 1, which can be a1, ak plus 1, a2k plus 1. All that is a series that decreases by 1. And we know that the maximum number is 13, so why not just take this to be 13, and we just keep decreasing, 12, 11, and there's no way for 10, right? So then again, the next terms, a2, a6, and A10, they must form an increasing series by 1. And we've already covered 1 to 4. So we'll fill this with 5, 6 and 7. Right? And then the next few, the remaining things, they have to be in a decreasing series. A3, A7 and A11. And we've covered 13, 12, 11. So we just take 10, 9, 8. And like that, we've just filled the array. You can check if you want, but this will give you a correct value, where by moving the s from just shifting the s across, it decreases by increases by 1 first, then decreases, then increases, then decreases, and so on. So that's the solution for this problem, and this is the code. So basically here you can see that here we take 1, 2, 3, 4, and then the next increasing part will be 5, 6, 7, 8, right? So for every increasing part, the starting point I store in low, and for every decreasing part, the starting point I store in up. So initially it's 1 and n, and whenever I'm considering a series of si, sk plus I, s2k plus I, and so on, that series is either increasing or decreasing. And if it's increasing or decreasing, that I store it in this boolean value increasing. And this position is basically the starting point of the series. So initially the starting point is 0, and if it's increasing, then I basically go through all the possible values at a distance of k. So I equals pos, I smaller than n, I plus equals k. And I keep increasing low by 1 and updating the answer to that, which is basically what I'm doing by doing 1, 2, 3, 4 and so on. And once I'm done with that, I just change increasing to be false, which means it's decreasing. And if it is decreasing, I'll be using the upper value and just, that is n, and keep decreasing n by 1 and increasing count by 1 every time. Count just keeps track of how many positions I filled. So that's how the solution works, and in the end I can just output answer to get my value, and that gets accepted in the context. So yeah, that's it for